Hello everyone, welcome back to our Engineering Graphics YouTube channel. Friends, in this session, we are going to solve another problem based on an isometric projection, and the problem statement is the orthographic view. The two orthographic views are given in the figure by first angle method of projection. Draw an isometric view taking O as a origin, use natural scale, give the basic dimension in view. Now, the front view and top view is given, and the origin O as a reference is given at the left bottom corner. Now we know that from front view we can measure length and height, and from top view we can measure length and width. Now for isometric view we required an isometric box. This box consists of three different axes, and on this axis we will mark length, width and height. Now here in this problem the origin O is given at the left bottom corner. So this is the length of this object, and for this problem this is x axis, this is y axis and this is z axis. Along x axis we are going to mark length of this object. So this is the length of this object, this is the height of this object, this is width of this object. Now when the observer is looking from front view or from x direction, observer will get length by height box. You can see this is the front view, this is the top view. When the observer is looking this object from top, then observer will get length and width. This is the width. So you can see here. So from front view and top view we can easily measure the maximum length, maximum width and maximum height. Now here from front view and top view we can measure the length. Now this distance from this corner to this edge distance is given 50 mm. From this edge to that center of that circular hole or half circle semicircle profile distance is given this 35 mm. From this center to this outer half circle radius is given 35 mm. So total length is 50 plus 35 plus 35. So length of this object is 120 mm. Height from base to top, height is 70 mm. From center to this edge distance is 35 plus 35. So height of this object is 70 mm. And width, in the top view we can measure the width, we can find the width, and width is 20 plus 30 plus 20. So 70 mm is the width. So friends, from front view and top view we can easily find length, width and height, and measure the maximum length, maximum height and maximum width. So for isometric box we required the overall dimensions. Now this angle x and y axis make 30-degree angle from reference line, from baseline. So using length, width, height, we can draw the isometric box first. So draw the horizontal line, mark point O, then mark 30, 90 and 30-degree angle. By using thin line, make this isometric box. So this is x axis, this is z axis and this is y axis. So along x axis mark 70 mm distance, along z axis mark again 70 mm distance because height of this object is 70 mm, and along x direction mark 120 mm distance. Now adjust the roller along z axis and draw the remaining two z axis. Now here you can see आपण दोन प्लेन बनवले आहेत. This is plane number 1, this is plane number 2. Now adjust a ruler along x-axis and draw the plane number 3rd. So we have completed the isometric box. This is x. Along x-axis we are going to mark length. हा y-axis आहे, त्यावरती आपण width मार्क करतो आहे. This is z-axis, त्यावरती आपण height मार्क करतो आहे. Now see the problem. This problem consists of two parts. The part number 1 and part number 2. The part number 1, it is a wedge shaped part, and you can see the profile O1, 2, 3, 4. This profile is, its position is here, in front or near to the observer. This profile have 70 mm thickness. But this half circular profile, its thickness is 20 mm, and the position of that half circular profile is at the center of that wedge shaped element. Now here O4 distance is not given. O4 height is not given. Do not assume anything. कुठलाही डिस्टन्स ॲझ्युम करायचं नाही आहे. तर हे डिस्टन्स आपल्याला फाइंड करायचं आहे बाय युजिंग रिड्रॉइंग द सेम प्रोफाईल. आपण ही O1, 2, 3, 4 प्रोफाईल सेपरेट ड्रॉ करणार आहोत आणि त्यानंतर हे O4 डिस्टन्स आपल्याला मिळणार आहे. तर त्यासाठी तुम्हाला आपल्याला ती जी प्रोफाईल आहे ती ड्रॉ करायची. O21 distance is 50 mm. From top view, we can find this distance. Height 1 to 2 height is 70 mm. 1 to 2 height is 70 mm. This 2 to 3 distance is 15 mm. In the top view, this distance is given. Now, from 3, the 45-degree angle is there. So we will mark 45-degree angle. Join this angle first, and then from O point we will draw the vertical line, and this vertical line gives the height. Again there is a, on this wedge shape part, there is a Z shape profile on the top surface. On the slant surface, या slant surface वरती ही Z shape profile आहे, and the position of this profile is 15 mm from O point. So we will mark, or we will show this profile 15 mm by using hidden line. We will show this profile. Now the height of this 4O is 35 mm. This height is 35 mm. Now we can easily draw this profile. This point is O, 1, 2, 3 and 4. Now see, we can start our problem from origin O. O21 distance is 50 mm. This distance, this 50 mm, we can mark along the x-axis. Then height is 70 mm along the z-axis. Now 2 to 3 edge we are going to mark on the reverse x-axis. This height O to 4 height is 35 mm. Now we have point number 3 and 4, so we can directly join point 3 and 4 by using a straight line. Now we can see this profile have 70 mm thickness along the width side, along the y direction. So add the thickness. This distance is 70 mm. Already 70 mm the distance is there. Now the same non-isometric line is appeared on 70 mm backside. So this edge ही जी एज आहे 3 to 4 सेम एज 3 to 4 appeared होणार दिसणार आहे आपल्याला 70 mm विड साईडला. सो डायरेक्टली वी कॅन जॉईन दिस टू एंड पॉइंट्स. These two lines are the non-isometric lines. On this slant surface, there is a Z-shape profile. So again, this distance is not given. And these two lines are the non-isometric lines. We can't mark angle on the isometric view. Now, for this Z-shape profile, आपल्याला ही प्रोफाईल विथ डायमेन्शन ड्रॉ करायची आहे. There is a gap of 30 mm and from both the end we can mark 60 degree angle. Find the midpoint of this gap. The gap is at 30 cm आहे. Center point midpoint मिळेल 15 वरती. Now this is a y distance. ही जी प्रोफाईल आहे वेज शेप झेड ची प्रोफाईल आहे त्याची लेंथ और along the x axis this distance is 15 mm. So this is 15 mm distance, but we can't mark this distance. It is a top view distance, but y distance is a true distance. So we will measure this distance and we will mark this distance on the vertical line. Then we can join this profile. Can make this profile. Now here, this is the y distance and this distance is the x distance. These angles are 60 degree, and the gap is 30 mm. The gap is 30 mm. Now here, for this profile, first mark this 15 mm distance along the x direction. This is 15 distance, and then we will project this distance up to the slant line. Then we will pass this distance towards the y direction. Now this profile is symmetrical. The gap, for this gap we can draw 20 mm distance, as well as this profile is at the center of that midpoint or center of that object. So first from both ends we will mark 20 mm distance, 20 mm. The gap is 30 mm gap is present here. Now again for this line we will find the center of that edge, which is at 35. The total length of this object is 70, so midpoint we will get at the 35. Now from this Z-shape profile we will measure the x distance, and then we will mark this x distance on both sides of that edge. These are the two non-isometric lines for Z-shape profile we have drawn. You can see here. This rectangular faces are there, 20 by 35. Rectangular faces are visible from the side view. Now you can see here. The depth of that Z shape profile is this slant surface to bottom. So this depth we can show with the help of this projection line. So adjust a ruler along this line and draw this line. By using this, we can show the depth of that Z shape profile. This is the depth of that Z shape profile. Now here, now we have completed the wedge shape profile. Now the part second is a semicircular part, and its position is at the center. So for this first we will find the center of that profile, and the thickness is 10 mm. So along this center line we will mark 10 mm on the right side, 10 mm on left side, and then we can draw a profile. This profile have again 70 mm height. So along the Z axis we will mark 70 mm distance. Now you can see here. On this profile there is a half circular part as well as circular hole. Now the diameter of that half circular section is 35 mm radius. So diameter is 70 mm. So for this half circle required 70 by 70 rhombus. So here this distance is 70 mm. This distance also 70 mm. Now from this point we will mark again 70 mm distance, and then we will find this rhombus. Its dimension is 70 by 70. Now find the center point of all these four sides of that rhombus. So center point is at 35. So by using roller or scale you can find the center, but if you measure 35 distance in the compass, we can easily mark a center. Now these two are the obtuse angle. Join obtuse angle and opposite side midpoints. By using thin line, join it. Now take a compass, and by using two centers for this half or semicircular part, take C center and this C1 and C2 center. From these two center we can easily draw this half circular profile. Now measure this distance in the compass and draw the 1/4 arc. Now place metallic pointer on C1 point and join it. Now you can see we have made this half circular profile. This profile is directly attached to that wedge shape element. This circular profile have 20 mm thickness. So along the y direction we will add thickness, and same arc is visible on the back side. So ह्या मागच्या सर्क्युलर पार्टसाठी हा C2 सेंटर आपण 20 mm टुवर्ड्स विड्थ साइड शिफ्ट करणार आहोत. सो अलॉंग 20 mm width side shift C2, we will get C2 dash point. For this arc, we have taken this radius. Take the same radius and draw the another arc which is parallel to that arc. I can see here. If you join this, we will get the profile which is seen at 20 mm backside. The bottom edge. Now this half circular profile have the circular hole of diameter 40. तर त्यासाठी आपल्याला ह्या रोम्बसचा सेंटर फाइंड करायचा आहे. Find the center of that rhombus and then हा सेंटर असणार आहे या रोम्बसचा. देन मार्क 20 mm 20 mm डिस्टन्स 20 mm toward left side, right side, up side and down side. So measure 20 mm distance in the compass and mark this distance on all sides and take the roller and make an isometric box. हे थोडं कॉम्प्लिकेटेड होणार आहे, बट जर तुमचं कॉन्सन्ट्रेशन असेल देन यू कॅन इझिली ड्रॉ the isometric box as well as circular hole. Now these two are the obtuse angle. So join obtuse angle and opposite side midpoints. Now here, this is the rhombus and these are the centers C1, C2, C3 and C4. Now take a compass and take this radius in the compass and draw the arc. Now हा जो सर्क्युलर होल आहे हा फुल दिसणार नाही, तो ह्या वे शेप इलेमेंटच्या मागे आहे. So join these 2 points only. Now take C2 center and join these 2 end points. Now take this C3 center join this, take this C4 center and mark a remaining arc. Now you can see here. This portion is not visible from the x direction, but there is a circular hole. So from C1, C2, C3 and C4 center we can draw this circular hole. Now this is a solution for this problem. Now give the dimension, give the overall dimensions to this object. This is 50 mm. This is 70 mm. Use the overall dimensions. This is 15 mm. R 35, 40 and the maximum length is from this face to the half circular part, its length is 70 mm. Now this is a complete solution for this problem. Try to solve this problem, friends. Thank you for watching this video. If you found this video helpful, please like, share and subscribe our YouTube channel. We will meet again in the next lecture. Thank you. Bye. Happy learning.